Here we go. I'm going to do a review of what we did on Friday. 30, 60, 90 triangle and a 45, 45, 90 triangle. Those are called special right triangles. Now in this case, the 30, 60, 90 triangle, the reason that they're special is the fact that you only need one side to figure out the other two sides. Now the relationship is, for instance, if we have some number here, whatever it is, the relationship between that side and the longest side looks like that. The relationship between the shorter side and the hypotenuse, one is twice as big as the other. Or if we go backwards, one is half as big as the other. Now the weird side is over here, and we would say, it just so happens that whatever that short side is, we would multiply it by the square root of 3. So to go from the short side to this middle side, I guess you would say, whatever that number is, you multiply it by the square root of 3. And going backwards, if you have that middle side and you want to go to the short side, you divide by the square root of 3. Now, the thing is, you know what? If you happen to have this side, you can always figure out this side, right? Well, you can go through the process and do the Pythagorean theorem between those two to get this last side. You can do that. It's a little bit more work, but you can always rely on that. So really, essentially, all you really need to do is remember these two, and then you can figure out the last side. But if you get the hang of this, it's a little bit easier. I'm going to do an example. Okay, hold on. So here's one. Let's just assume that, for argument's sake, I'm just going to pick a number. How about 5? This side is 5. Well, that means that the longer side, the hypotenuse, is going to be twice as big, which is 10. Now remember, I can just use the Pythagorean theorem and use this as A and this is C and figure out what B is, right? A squared plus B squared equals C squared, Pythagorean theorem. But a shortcut is that I know that if I take this number right here and multiply it by the square root of 3, that's that side. Okay, there's a quick example. Here's a more challenging question. Now let's just say that you have this 30, 60, 90. Now notice, I don't have to have this 60 over here because I already know that this angle is 30, this is 90, so the last one is 60. Anyway, now we're going to go backwards. I know that this number right here is square root of 21, whatever that is. I'm just going to keep it the square root of 21. Well, how do I go to the short side over here? Divide by the square root of 3. Let me do that here on the side. Let's see. The square root of 21 divided by the square root of 3. Now, another way to look at that is it could also be written like this. Big square root of 21 over 3. Now 21 divided by 3 is 7. So we really end up with, this is the square root of 7. I just took square root of 21 divided by 3, because I'm going backwards this way to get that side. Now if I want to find the hypotenuse, well, it's twice as big as that square root of 7. Oh, twice as big would be 2 times the square root of 7, twice as big. There you go. I hope that's helpful. All right, let's go to 45, 45, 90. So one way to think about this is, imagine this is a square, right? 4 equal sides. And you cut this thing in half. Well, all the angles are 90, so if you cut the angles in half, you got 90 there. Half of 90 is 45, so it's half of a square. Okay, so now we say, well, if it's a square, I'm just going to pick a side. I'm just going to make this up. Let's just say that this is 8 inches, and then that means that this side is 8 inches. And we can, again, use the Pythagorean theorem. A squared plus B squared equals C squared. Now, you can always do that, but there is a little bit of a trick. If you simplify it in the end, the result is going to be whatever this side is, multiply it by the square root of 2. So this is going to end up to be 8 times the square root of 2. Now that's only for a 45, 45, 90 triangle. Like I said, these two are special right triangles. Okay, let's see. Should we do an example? Sure, I'll do that. So here's a triangle. It's an isosceles right triangle, which means that the two angles are equal. So we've got our 45, 45, 90. Now imagine you have a starting point here, and you have two people, and one person goes in one direction 13 yards, and then the other person goes in the other direction 13 yards at a right angle. Well, when they stop, so this person stops over here, and this person stops over here, how far apart are they in the end? Okay, well, the answer is not 13. It's 13 square root of 2. 45, 45, 90 triangle. Again, one more time. You could do the Pythagorean theorem, or you could just say, oh, I understand these special right triangles. You would say 13 times the square root of 2 will give you a number, and that's how far those people are apart from each other after they walk away from each other 13 yards. Okay, let's do one more thing. Now here's a challenge problem for you, and I would love to talk about this the next time I see you next week. A family moves into a new house. Now there's a really big bedroom in the house, and the family has 3 kids, and all 3 kids are going to share this bedroom. Now the width of the bedroom, like this, is 20. Now we don't know what the long side is yet. We just moved in, but we do know that the Wi-Fi is built into the corner of this room, and it can't be moved. It's right in the wall. Now the kids are arguing because they want to divide up this room into their own little space. That seems to be fair. But they want to share the Wi-Fi equally. Now, how would you divide up the room considering that the Wi-Fi is coming from this area right here? If you divided it up like this, now this kid would get most of the Wi-Fi, the better Wi-Fi, and this kid way over here, maybe it would be a little bit slower. So let me show you what they did, what they decided in how to divide up this room. So this is what they came up with. The younger kid gets this smaller area, and then the middle kid gets this one, and the older kid gets this area right there. So that's that area of the room, and they think that they're going to be able to share the Wi-Fi equally that way. Well, here's my question. My question is, what is the perimeter and area of each one of these triangles? Now, here's my hint to you. Let's see. Well, it is a rectangle, right? So these are right angles, aren't they? And when they divided this angle, right, each one of these was an equal angle. Here's my other hint. My other hint is that we are going to use the 30, 60, 90 special right triangles. Now, if you could figure out, it's kind of a big problem, if you could figure out the perimeter, right, of each one of these triangles, that's the 3 sides added up, and the area, oh, I better tell you that, just as a reminder, the area formula is 1/2 base times height. 1/2 base times height. I think you guys remember that, okay? So, those are the types of things you're going to use. Let's see how far you get. This is a good problem. I really like this problem. Okay, have fun, and I will see you later.